This is CPM Precalculus chapter 3 number 88. So here we're asked to graph two functions. F of x is 3 to the x power and g of x is log base 3 of x. Okay, what you're going to notice here right away is that these are inverses of each other. Okay, just like we've done in class. And also we want to state the domain, range, and any zeros of each function. Alright, so let's go ahead and do this. Let's go ahead and graph our functions, drawing the x-axis and the y-axis. And right now we can plug this one into our calculator easily, and we don't know how to plug this one into our calculator, at least not yet. So let's go ahead and look at it in our calculator, f of x in red. So I'm going to turn on my calculator and go ahead and graph y equals to 3 to the power of x, right? That's f of x. Graph it. I'm going to see that it takes this shape just like that, right? So I'm going to go ahead and use red and graph it. Okay, so here is f of x. It looks like it goes like this and stops, right? Oops, I didn't do very well, right? But actually these go on forever towards negative infinity and up towards infinity up there. Okay, so that's f of x right here. And let's go ahead and get some points. Let's label some points. So right here, I know the x value of this point is 0. Well, what is the y value? So if I plug in x into f of x, 3 to the 0 power equals 1. So this point right here is 0, 1. Okay, and that's how I can figure that out. Right here at, let's say this is, I don't know, let's use orange. Let's say this is 1, 2, 3, and -1, -2, -3. But going up, this is 1, 2, 3, 4, -1, -2. Put those a little closer together. Okay, so there is f of x. And let's draw one more, let's label one more point. At x is 2, let's say at x is 1, the y value, we plug in 1 into x, so that's 3 to the 1 power. So right here, I guess it's not perfect, but let's say this point right here is 1, 3. Okay? So now that we have done that, how are we going to get this graph, g of x? So I'm going to get into green, yes. And we know that, well, before I get into green, I'm going to go back to orange, that these two functions are inverses of each other. And that means a couple things. That means, one, you swap x and y, and then that's the inverse. And also, there's a reflection across the line y is equal to x. Reflect across the line y is equal to x. So if you were to graph the line y is equal to x, I'm going to do it with dashes. It's going to look like this, right? That's the line y is equal to x right here. And if we reflected everything across this line, this point in red, we're going to get the inverse of it, which is g of x. Okay, so right now this point is at 1, 3. If we reflect it across, it's going to now be at 3, 1. Okay, and it might not be drawn to scale because, as you can see, my vertical units are much smaller than my horizontal units. If you made the units the same length, right, then it would be perfectly diagonal in the middle, and it would be really symmetric looking, while it is very symmetric in real life. Okay, so this point 1, 3 becomes 3, 1. This point at 0, 1 becomes 1, 0, and so on, right? So here we're approaching negative infinity, and here we're also going to be approaching negative infinity, and our graph is going to just cross through these points like this. Okay, Again, that's 3, 1. So here are the sketches of each graph. So now let's go ahead and state the domain, range, and zeros of each. Okay, so the domain of f, remember we're going from left to right when we're looking at domain, and we're just looking, is there x value? Yes, 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 yes. And there are x values everywhere. There are x values that give us an output of y. This arrow is going up and also to the right. Even though it's not like the slope is very high, it is going up and to the right. So we're getting y values for every possible value of x. So our domain is going to be from negative infinity to infinity. Our range for f of x is, well, do we have any, when we have this x value down here, going from down to top, when do we start getting, when do we start hitting our graph? Okay, so we start hitting our graph right after our x-axis, okay, because this in red doesn't cross the x-axis here. It just barely goes over it. It approaches it. Eventually you're going to think that it touches it, but it never does. The x-axis is like a horizontal asymptote because our graph f of x never crosses it. So anyway, the range then is no, 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 no until we get right above the x-axis, which is 0 in the y direction. So it starts at 0 but excludes 0 and goes all the way up, because yes, 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 all the way up to infinity. Okay, and zeros are where does f of x cross the x-axis? Okay, so remember, zeros are where our graph crosses the x-axis, right? And do you see any place that our graph intercepts with the x-axis? No, so none. Okay, so now let's go on to do the domain and range of g of x. Domain, remember we're starting from left to right and we are looking at vertical lines, and so far it's no, 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 no until we cross the y-axis, right? So once we cross the y-axis right here, immediately after 0 we start to get values on our function. So starting at 0 and going to the right to infinity, but excluding 0, so we have a open parentheses. Our range, when we look at it, our range, we start down here and we look all the way up, and yes, we're crossing our function with every possible horizontal line. Again, this, it looks like it might be going to the right, but it's actually going up and to the right. So we're going up to infinity as well. And finally, what are the zeros? Well, again, the zeros are where we cross the x-axis and we intersect the x-axis right here at this point, which is 1, 0. Alright, so that is the domain, range, and zeros of each function. Here in green, again, I'm going to write it, we have g of x. Alright, so that ends for us CPM Precalculus Chapter 3, number 88.